Hello, wonderful Java learners. Welcome back to our channel. Today, we are diving into a super exciting and powerful topic, Java multithreading and concurrency. Have you ever wondered how your computer can do multiple things at once, like playing music while you are browsing the internet? That is exactly what multithreading helps us achieve in our Java applications. In this beginner-friendly tutorial, we will understand what multithreading means, why it is so important for building responsive and efficient applications, and how to implement it using simple Java code. By the end of this video, you will have a solid foundation to start writing concurrent Java programs. So, let us get started, shall we? Alright, let us start with our first core concept, how to create a thread by extending the thread class. Think of a thread as a lightweight subprocess within your main program. Our main program runs on one thread, and we can create more threads to perform tasks in parallel. To do this, you simply create a new class that extends Java's built-in thread class. Inside your new class, you must override the run method. This run method contains the code that the new thread will execute. Once your custom thread class is defined, you create an object of it and then call its start method. Remember, calling start is crucial. It allocates system resources for the new thread and then calls run. Let us see a quick example. Now, let us explore another, often preferred, way to create threads by implementing the Runnable interface. While extending the thread class works, Java follows the principle of single inheritance, meaning a class can only extend one other class. If your class already extends another class, you cannot extend thread directly. This is where Runnable comes to the rescue. The Runnable interface has just one method run, which you need to implement. After implementing Runnable, you then create a thread object and pass your Runnable instance to its constructor. Then, just like before, you call the start method on the thread object to begin execution. This approach offers more flexibility and is generally recommended. Let us look at the code for this. Excellent. We have learned two ways to create threads. Now, let us put them into action with a practical example to see how they run concurrently. In this example, we will create instances of both our myWorkerThread class, which extends thread, and our myWorkerRunnable class, which implements Runnable. Then, from our main method, we will start both of them. Notice how the output from both tasks will be interleaved, demonstrating that they are executing in parallel, not one after the other. The start method signals the Java virtual machine to create a new execution path for our thread, allowing the main thread to continue its work while the new thread performs its task. This is the magic of concurrency. Observe the code and its potential output. As you dive deeper into multithreading, it is important to be aware of some common pitfalls. One of the biggest challenges is managing shared resources, leading to what we call race conditions. A race condition occurs when multiple threads try to access and modify the same data simultaneously, leading to unpredictable and incorrect results. A common mistake is not synchronizing access to these shared resources. Another beginner mistake is calling run directly instead of start. Run will simply execute the code in the current thread, not a new one. To avoid race conditions, Java provides mechanisms like the synchronized keyword, which ensures that only one thread can access a critical section of code at a time. Also, explore the java.util.concurrent package for powerful tools. Always think about data safety. Fantastic job, everyone. We have covered a lot in just a few minutes. Let us quickly recap what we have learned today about Java multithreading and concurrency. First, multithreading allows your Java programs to perform multiple tasks simultaneously, making them more efficient and responsive. Second, you can create threads either by extending the thread class or by implementing the Runnable interface, with Runnable often being the more flexible choice. Third, always remember to call the start method, not run, to actually launch a new thread. And finally, be cautious of race conditions when dealing with shared resources and use synchronization techniques to keep your data safe. Keep practicing these concepts, and you will be a concurrency master in no time. If you found this tutorial helpful, please give it a thumbs up, share it with your friends, and do not forget to subscribe for more amazing Java content. Happy coding!